Good morning, everybody. Welcome to this online video lecture. In this session, we'll be discussing chapter number 2 of Wooldridge's book. You'll be required to do some reading and do some math stuff in this session as well. Let's just start off with a review. We So things to learn in this session are what are we trying to do. So for that, we'll be reviewing some stuff that we've already talked about. Then we'll talk about what ordinary least squares means, and then we'll try to derive the beta naught and beta 1, which are the estimators. Once we've derived these estimators, फिर हम करेंगे ये कि we will be trying to see if we can calculate these beta 1 and beta naught manually. So for you guys, you'll have to do it in the exam by hand. In this class, I'll be using Excel to help us with this, but the method is the same. Once you figure out how to do it in Excel, you'll be able to do it by hand as well. So let's just start. What we're trying to do is that we want to try to figure out whether two variables x and y are related to each other or not. And what we're trying to explain in specifically is that does variation in x cause variation in y or not? So does changes or do changes in x kind of help in explaining changes in y or not? So that's the main idea. And when we start off with this process of trying to figure out whether um, this relationship holds or not, a few questions that we come across is first, how do we uh, take into account other factors, uh, y, z, that might be impacting y as well? How do we do that? Besides this, another question that we need solving is how do we establish causality? So, causality, if you recall from our last session, needs to be established by assuming the citrus paribus uh, thing. How do we go about doing that? If we want to figure out uh, or establish the fact that x causes y, we need to establish citrus paribus. We need to assume that everything else that might be impacting y, uh, capital Y and Z, are going to be assumed constant. But how do we do that? So to do that, we come up with a simple linear regression model, which looks like y is equal to b naught plus b1 x plus mu. So we're trying to figure out the relationship of x and y in the population. How are x and y related? Does x cause y or not? And what we do is we look into, or we solve this problem by assuming that all of those components that might be impacting y are assumed to be part of this term over here, which we'll be calling the unobserved term or the error term. And we've already talked about what dependent variables are and what independent variables are. X is your independent variable, y is your dependent variable. Beta naught is the y-intercept, and beta 1 is your slope term. So in order to, the challenge over here is to find the value of beta naught and beta 1 uh, using the sample data, and then be able to establish that the sample actually, the data's beta is actually representing the population as well. And there are other concerns about causality as well, which we'll deal with as we progress through this course. So starting off with this simple linear regression, there are a couple of assumptions that we need to make. So what are these assumptions? So first, let me just write down the linear regression model again, which looks like y is equal to beta naught plus beta 1 x plus mu. A couple of assumptions regarding mu need to be made. The first assumption is that the expected value of mu in the population is 0. The mean value of your unobserved component is uh, assumed to be 0. The second assumption that we're going to be making is that the expected value of mu for any given x is the same, which is the expected value of mu. So it's constant. It's not dependent on y. So it's independent of x. Sorry, not y, x. So the mean value uh, of the unobserved component is not dependent on x. And we've just, in the first assumption, assumed that the mean value of the unobserved component or the error term is 0. So what we're saying is the second term is called the conditional mean, zero conditional mean assumption, which is saying that the mean value of the error term given any value of x is 0 in the population. What this helps us do is it helps us come up with this population regression function, which looks something like the expected value of y given any value of x is beta naught plus beta 1 x, and then we just assume that expected value of mu given x is 0. So we come up with this. And this over here is called the population regression function. So what it's saying is that if we knew the value of x and the value of beta naught and beta 1, we'd be able to come up with an expected value of y. Please understand that we're talking about the average value of y, not the actual value. If you knew, for example, if y in this case was, let's say, earning, and x was education. So what we'd be saying is, for example, and let's just pose some values over here. Beta 1 is, beta naught is 100 plus beta 1 is 0. Is, let's say, 10, 10. And then you have education over here. So what we're saying is that earning, the expected value of earning given any value, any amount of education would look something like this. So if, for example, somebody's education, somebody had 10 years of education, 10 to 10, this would mean that on average somebody with on average is what I'm trying to stress at. On average, somebody with an education of 10 years would have an earning on average, not exactly. Not everyone is going to have not everyone is going to be earning 200 rupees. On average, they'd be earning approximately 100 rupees. So this equation is called the population regression. Now that we've talked about this, let's just talk about how do we come up with these values. How do we come up with this 110 that helps us come up with this value of 200? So once again, I'd like to reiterate that we're trying to figure out the relationship between x and y, but in the population. But since the population is difficult to get data of, you use a sample. And we'll be using a sample to kind of figure out the value of beta naught and beta 1. So let's just start off with our discussion on how we want to come up with the OLS estimates. So the OLS is called the ordinary. So it's the ordinary least square method of, so it's one method with which you can calculate the value of beta 1 and beta naught. So we're talking about ordinary least squares. So this is the method that we want to use to find out the value of beta. So before I get into the maths of finding of how to find the value of beta, I just want to go over the procedure that and try to graphically explain to you how the software kind of finds out the value of beta 1 and beta 2 for you. So let's suppose we're taking that same example again, in which we have this equation which looks like y is equal to beta naught plus beta 1 x plus mu, and we're interested in finding the value of beta naught and beta 1 for the population. And in order to find the values of these things in the population, what we need to do is that we need to go into take a sample data. Let's just suppose that y in our case over here is earnings, and x over here is education. तो बेसिकली हम करने की कोशिश ये कर रहे हैं कि हमने ये अज्यूम कर लिया कि यार अर्निंग और एजुकेशन के दरमियान में हम रिलेशनशिप फिगर आउट करने की कोशिश करें. अब इसको फिगर आउट करने के लिए हमें जाके लोगों से डेटा कलेक्ट करना पड़ेगा. और फॉर एग्जांपल आई वुड बी गोइंग अराउंड आस्किंग पीपल कि यार बताओ तुम्हारी मल्टीपल लोगों से मैं पूछूंगा कि यार तुम्हारी अर्निंग कितनी है और तुम्हारी एजुकेशन कितनी है. सो लेट्स सपोज कि मैं को 5 लोगों से जाकर पूछता हूँ कि यार 1 2 3 4 5 तुम्हारी अर्निंग कितनी है. अर्निंग कितनी है, वो कहते हैं 10 लाख रुपए है, और दूसरा कहते हैं मैं 20 साल की एजुकेशन है. सो ऑन सो फोर्थ आई गो एंड कलेक्ट द डेटा. सो दिस डेटा इज बेसिकली रिप्रेजेंटेड एज गोइंग फ्रॉम 1 to n. और इसको हम लिखते हैं इस तरह है, जैसे y के नीचे सबस्क्रिप्ट डाल देते हैं i का. सो i इज समथिंग दैट रेंजेस फ्रॉम 1 to n. सो 1 से लेके n तक के लोगों का सैंपल है. एंड by i beta naught plus beta 1 xi plus mu i. ये जो पहला बंदा जो है वो x वो y1 होगा. y1 की अर्निंग 10,000 है, और उसकी उसी बंदे की ये जो i1 होगा तो उसकी x है वो 20 है. Right? So that's how you collect data, and this subscript tells you कि आप basically at the moment cross sectional data को देख रहे हैं. So you're taking data from multiple people at this point in time series का component इसमें नहीं है. अच्छा, now that we've done this, so अब ना we've gone around asking people for data. Now we have the data. So the next step is कि we have to use that data to come up with the value of beta naught and beta 1. So graphically speaking, so that you can visually understand what's happening is कि आप वो 5 लोगों का डेटा कलेक्ट करते हैं about their education and earnings, और उसको प्लॉट कर लेते हैं on a graph. So it looks like this. You have earnings over here and ED education over here. और मल्टीपल उनका जो डेटा है ना वो प्लॉट कर देते हैं. इस तरह करके ना यू प्लॉट ऑल ऑफ देयर डेटा 5 लोगों का आपने इस तरह. Now once you have this, what the software starts doing is it starts coming up with best fit lines. So आपने मैथ्स में पढ़ा होगा what a best fit line is. So the software starts coming up with different best fit lines. एक for example best fit line ये है, और इसी तरह की एक और best fit line could have been, I don't know, this doesn't look like a best fit line. So now let's just figure out how to come up with the ordinary least squared betas. So we'll start off with the fact that we're trying to minimize the sum of squared residuals का square. यह minimize करने की कोशिश कर रहे हैं. And recall that your predicted value was actually beta naught plus beta 1x. So this component can we'll be using later, and this is, if you recall, simply just the error of your model. So we were trying to minimize the squared residuals in order to come up with the values of beta 1, beta 2. So first step is just to replace this predicted value by beta naught plus beta 1x. So we're trying to minimize summation y minus beta naught plus beta 1x. This is what we are trying to minimize. So now that we've got this term, in order to find out the values of the betas, what we're supposed to do is we start off by taking the derivatives with respect to beta naught and beta 1 of this particular term. So this is, and then you put it equal to 0. So if you've covered any kind of optimization in your uh, maths or stats classes, this is what you must have learned. So we'll start off by differentiating this term with respect to beta naught. So we differentiate with respect to beta naught first, and after that we'll differentiate it with respect to beta 1. So going back to how you differentiate, so you ignore the summation and then you differentiate the whole term, but before that you bring the power down. So you bring the power down, and so you keep the whole term as it is, beta naught minus beta 1x, and subtract 1 from 2, so you're left with 1, and then you multiply it by the actual derivative of this term. So since we're differentiating with respect to beta naught, so the derivative of beta naught with respect to beta naught would become minus 1, and then you have to, let's put it as equal to 0. And recall from our previous sessions that we've had together that constants can be taken out of the summation sign, and you're left with summation y minus b naught minus beta 1x is equal to 0. Uh, this beta is lost, so you don't need this. So I'm just removing it, and now you can just multiply the summation sign inside the bracket, and you end up with sigma y minus sigma beta naught minus sigma beta 1 x is equal to 0. And recall in our previous session when we were talking about summation rules, we said that if there is some term in which there is a constant, you can write it as n times beta naught, and you can always take the constant out of the summation sign as well. So you can convert it into beta 1 sum of x is equal to 0, And now, if you think about it, we're trying to find the value of beta naught, and beta naught kind of looks something like um, summation y minus beta 1 summation x divided by this n, and now what we just got over here is just move it up a little bit, and we have just come up with this thing beta naught is equal to, we call sum of something divided by the total observations is basically the mean value of y bar minus p1, the mean value of x bar. So this is what we'll be using later on to derive the value of beta naught. So this is basically step number one. Step one, or this is basically the value of beta naught. If you knew the value of the average value of y and the average value of x and the value of beta you'd come up with, you'd be able to get to the value of beta naught. Uh, the value of beta naught, and now we have to derive the value of beta 1, which is the slope coefficient. So let's just start off by coming back to this expression once again. Let me just remove the rest of the things from here. Just like we differentiated for beta naught, now we have to differentiate with respect to beta 1, and the same uh, it's just like how you differentiated for beta naught. So, and so you start off by bringing the power down, and this expression remains the same, and then you differentiate the term inside the bracket with respect to beta 1. So you end up with minus x, and you make it equal to 0. Now this minus 1 and 2 you can take out of the bracket, or you can just decide to keep it as it is. Let's just take let's just um, let's just take it out. I think maybe that's the best. Maybe that's the best approach to solving for this. So let's just do that. Let's take minus 2 out, and you're left with y minus b naught minus b1x times x. This and this is equal to 0, and now you can just remove the minus 2 out of the equation. And now you open this up. So you end up with yx minus beta naught x minus beta 1 x squared equal to 0. And now you can actually substitute this equation that you derived earlier for beta naught into the equation, and you end up with sigma yx minus y bar minus beta 1x bar times x minus beta 1x squared equals to 0. So this expression becomes yx minus y bar x, and once you multiply minus x by this term over here, you end up with a positive beta x bar x minus beta 1x squared, and this is equal to 0. Now you can actually multiply the summation inside, and you end up with summation xy minus summation x, and you can take the y out because it's constant. You can take it out if you want. And similarly beta, so this was beta 1 x bar can be taken out of the summation sign, x minus beta 1 summation x squared, and this is equal to 0. So let me just move all of this around a bit so that we have more space, and then we can continue on with the analysis. Put this over here, and then we take this and shift it up a little bit. Just bring it over here and continue solving for beta. We're trying to find the value of beta 1 at the moment. So now this equation is sigma xy minus, recall that we can convert the average into sigma y over n, and it's getting multiplied by sigma x, plus beta 1, recall we can convert this into sigma x over n into sigma x. So I'll remove the into sign over here because it might cause some confusion over here. Into sigma x minus beta 1 sigma x squared is equal to 0. And now you see that you have this term over here. You can write it as sigma x whole square. So you end up with sigma xy minus sigma y sigma x over n plus beta 1 sigma x whole square over n minus beta 1 sigma x whole square equal to 0. Now we can take the terms with the betas to one side and the rest on the other side. So let's just take these on that side, and you end up with sigma xy minus sigma x sigma y over n is equal to beta sigma x square minus beta 1, sigma x the whole square over n. Beta common out of this expression, you end up with beta 1 is sigma x whole square minus uh, sigma x the whole square over n is equal to sigma x y minus sigma x sigma y over n. And then you can take this term and divide it by the both sides, and you end up with beta 1 being equal to sigma xy minus sigma x sigma y divided by n divided by sigma x squared minus sigma x the whole square over n. And now you can multiply the whole thing by n, and eventually both the denominator and numerator by n, and you can end up with n sigma xy minus sigma x sigma y divided by sigma x squared minus, sorry, n times sigma x squared minus sigma x the whole square. And this equation over here is the value of beta. And in the next step, what we'll be doing is that we'll be using Excel and some observations to see how you can, using a piece of paper, come up with a value of beta 1, beta 2, which are the OLS estimators. And now what we'll be doing is we're going to Excel, and using what we've derived so far, we'll try to figure out if we can actually find out the values of beta naught and beta 1 or not. So let's go to Excel and see how that turns out. अच्छा जी, so recall के हमने ये दो formulas derive किए थे, और I told you that there's a problem with what I did with the derivation of beta 1. आप लोगों ने identify करना है इसमें क्या है गलती. So मेरे formulas को जो ना, I brought the formulas into the Excel sheet so that I know कि मैं काम क्या करूँ, इसको इस्तेमाल, what do I need in order to calculate the value of beta 1, beta naught directly from data. And data मैंने इस तरह किया कि I have taken data from 5 people, 1 to 5, so 1 to n, and उनसे ये पूछा कि अपनी earnings बता दें, अपनी education level बता दें. So first person said कि मेरी 1.5 लाख तनख्वाह है, मेरी 20 साल की education है. The last person said कि मेरी 50,000 तनख्वाह है, 10 साल की education का level है. And the rest you have over here. अब हमने करना ये है कि हमने beta 1, beta naught derive करना है. That is going to be the ordinary least square method. These beta naughts and beta 1s that you get will give us the values of the slope and the intercept that are the kind जिसके अंदर जो error in your prediction from actual value is the minimum when compared to the other estimators of beta naught, beta 1. Acha, since now that we've got the data and we have somehow got an idea के formula क्या है, so let's just see कि हमें क्या क्या चीजें चाहिए. हमें x और y का sum चाहिए, हमें sum of x चाहिए, sum of y चाहिए. Sum of x, sum of y तो बड़ा आसान है, इनको sum करेंगे तो sum of all of these numbers will give us the sum of x. So ये sum of y, so this is a sum of y, or similarly sum of x जो है, it's the same thing, add करके divided by the number of observations जो n है, and over here is 5. So n is actually 5 values, right? So n हो गया, sum of x हो गया, sum of y हो गया. अब x और y के multiple को आपस में multiply करके उनका sum भी चाहिए. So we have x और y multiplied together. So this would be this into this into this, और ये हम इधर तक ले आएंगे और इनका sum है वो करेंगे. This is the sum of x into y. और क्या चाहिए हमें? हमें x square का sum भी चाहिए. तो यहाँ पे let's just have x square as well. X square is basically these values, this column into it into it again. तो x की values का squares हैं वो आपने निकाल लिए यहाँ पे. This is sum of x squares, और ये sum कितना है, वही formula sum लगा के ना you added them together, so ये sum हो गया. So sum भी हो गया, sum of x भी हो गया. अब आपको एक और भी चाहिए, which is इस x square का sum भी चाहिए, sum of x का भी square चाहिए. So sum of x का square is going to be sum of x का square is going to be 81 into 81 again. So आपके पास n पता लग गया आपको, sum of x y पता लग गया, sum of x पता लग गया, sum of y पता लग गया, sum of x square पता लग गया और sum of x का square पता लग गया. So now you have all the things needed to calculate the value of beta 1. अब करेंगे ये कि आप you put it in a cell, beta 1 की value is आसानी के लिए आप denominator और numerator को अलग-अलग solve कर लें, but if you don't want to do it, fine, that's completely up to you. So n multiplied by sum of x into y. Sum of x into y is this. ये हो गया minus sum of x into sum of y. Minus sum of x into sum of y. और इनको सारों को मैं ब्रैकेट में डाल रहा हूँ because ये टॉप वाला पोर्शन है. And then you divide this by नीचे वाला portion is, what is it? It's n, which is 5 again. एक और ब्रैकेट में करते हैं 5 into sum of x का square, x square का sum is this, minus x के sum का square. And if you do this, you get the value of beta naught. Now beta naught की value हो सकता है आपने गलत निकाल ली हो, but you want to verify this. But चलो उसको हम थोड़ी देर बाद verify कर लेते हैं कि किस तरह verify किया जा सकता है. The second thing that we wanted to find out or estimate was beta naught. Beta naught is the intercept. Intercept का formula क्या था? Y bar, which is the average of y, average value of y data में. तो हम करते हैं कि average of y निकाल लेते हैं. Average कैसे निकालते हैं? Excel में average कितने नंबरों की, 5 नंबर की एवरेज सिलेक्ट करेंगे डेटा, ये एवरेज ऑफ y आ गया और एवरेज ऑफ x भी चाहिए आपको. तो मैं इसको वैसे ही ड्रैग कर लूँ ना इधर नीचे x के नीचे, तो आई गेट द एवरेज ऑफ x और आपको साथ में बीटा 1 की वैल्यू चाहिए. सो नाउ दैट यू हैव y bar, which is, so you have y bar and you have x bar. अब उसका इस्तेमाल करके आप बीटा नॉट की वैल्यू निकाल सकते हैं. y bar is this minus beta 1 times x bar, and this is how you get the value of beta naught is in beta 1. अब आपके पास बीटा नॉट बीटा 1 आ गया. अब आपने कहा यार हो सकता है कि गलती हो गई हो कैलकुलेशन में, ये तो हाथ से काम करने वाली बात है. तो देयर आर टू वेज इन एक्सेल जिसके अंदर आसानी से आप पता कर सकते हैं कि आपका डेटा आपने सही कैलकुलेट किया, फार्मूला सही लगाया. द फर्स्ट इज स्लोप का फार्मूला, इक्वल्स टू स्लोप. तो स्लोप के फॉर्मूले में पूछता है बताएं y कौन सा है और फिर कहता है बताएं कि x कौन सा है, कॉमा लगा के ना x कौन सा है. यू डू दिस तो आपके पास स्लोप की आ जाती है वैल्यू, बीटा 1 की वैल्यू. यू वेरीफाई, यहाँ पे करेक्ट है. सिमिलरली इसी तरह इंटरसेप्ट की भी मेरे ख्याल से, हाँ इंटरसेप्ट की भी आपको है, वो कहता है y की वैल्यूज बताएं, x की वैल्यूज बताएं, आपको इंटरसेप्ट कैलकुलेट करके बताते हैं. एंड y इज दिस एंड दिस इज x. you specify them and देखें आपके पास बीटा नॉट और बीटा 1 की वैल्यूज वेरीफाई हुई. थर्ड थिंग is कि यार चलो यार ये तो मैं गलत कर रहा हूँ, and a lot of times यार most of you guys will not be using Excel to do this. You'll be using Stata वगैरह, but Excel in itself also has this feature to calculate those kind of the kind of results that Stata and other EViews के proper software calculate, and वो है data analysis के अंदर. So sometimes you don't have this data analysis का की option available. तो Excel add-ins में जाके ना यहाँ पे you can analysis pack को activate किया जा सकता है. और फिर the idea is कि आप आप करते ये हैं कि आप जाते हैं इधर tools में, आप करते ये हैं कि आप जाते हैं टूल्स में, कम ऑन, go to data analysis और वहां से आप regression चूज करते हैं. in regression you say you specify आपकी y range कौन सी है, then you specify कि आपकी x range कौन सी है. आप range specify करते हैं and then you click OK, and that's when the regression analysis happens. एंड दिस इज वो द सॉफ्टवेयर डूइंग द एनालिसिस एंड वो आपको बताता है कि जी आपके इंटरसेप्ट की वैल्यू ना इतनी होनी चाहिए थी और वाई की वैल्यू इतनी होनी चाहिए थी. नाउ दैट यू हैव दिस विद यू, now this is what your predicted equation looks like. You're like y is equal to minus 5. So y is actually your earnings equal to minus 0 minus 5 3 4 5 0 5 5 3 4 5 0 0.7 plus beta is 5.35 times your education. Now once you have this, अब इस फॉर्मूला के अंदर एजुकेशन की वैल्यू डालेंगे तो आपको अर्निंग्स की एवरेज वैल्यू शायद प्रिडिक्टेड वैल्यू पता लग जाएगी. You can find out the predicted value of earnings based on the regression line that was derived using the ordinary least square method. I hope आपको थोड़ा बहुत ये समझ में आ गया हो कि ये क्या किया है. अच्छा जी, so this is the class assignment. You require to spend the next 1 hour doing this. So आपने बेसिकली करना ये है कि ये टेबल जो है बनाना है ऑन अ पीस ऑफ पेपर और इसके ऊपर यूजिंग द सेम मेथड दैट आई यूज्ड इन एक्सेल आपने वही मेथड फॉलो करना है टू फाइंड द वैल्यूज ऑफ बीटा नॉट एंड बीटा वन. And once you have them you will be able to come up with an equation जिसको यूज़ करके आप वो जो सवाल में prediction की requirement है वो आप सॉल्व कर सकते हैं. So good luck.